And gentlemen, thank you for joining us this evening. It is March 18th, and tonight we're going to be talking about serverless apps hosted in the Azure cloud. Our speaker tonight, Jeremy Brown, will be talking about how easy it is to get started with serverless apps and what a great way it is to get your feet wet with the cloud. And with that, I'm going to turn it over to Jeremy.
So what's happening, everyone? My name is Jeremy Brown. I'm kind of built this out of wanting to know myself. I'm a kinesthetic learner, and I feel like serverless kind of seems to be like the what's the tonic that used to be sold that was the cure-all tonic. Whenever you hear people talk about serverless, it's always it'll cure your ails. And so I was like, is it really as good as people say? Like, what's it for? How do you use it? And you go read about stuff, everything's so ephemeral. And I was like, the best way to learn it is to just get in and do it. So I decided to build myself a derpy web app that solves a problem I could have just Googled. And in doing so, I got to learn serverless out of it. So this talk kind of serves to show some of my journey through that and show everyone else a way that serverless can be applied, which will kind of ground it and root it so that people can start to see how awesome it can or can't be for different workflows and options that you might be looking at. And I have an ulterior motive in this, which is when I talk to a lot of people, everybody's afraid to get in and mess with the cloud because it's too expensive. They're always afraid that it's going to blow their bank account. And as long as the word virtual machine, or up until recently, the word database didn't come out of your mouth, you really didn't have to worry about it. Like, it's super cheap, and I want to kind of show that and prove that to you guys. So at the end of this, I plan on actually logging into my invoices, and we'll take a look at the cost that I have spent in Azure over the last 12 months. And well, granted, again, the word virtual machine never really comes out of my mouth, so I stay at the platform or higher. And so we'll see just how much money I've spent, my real money, and prove to you that the cloud doesn't have to be very expensive. So that's kind of what my goal is through this, is to show some of that application, and then at the end of it, maybe inspire you to go spend a couple dollars. So a little bit about me. Jeremy Brown. You can find me on Twitter and GitHub with Banana Jamma, somewhat similar to each other. And if you want to reach out to me over email, you can always hit me up at jeremy.isaac.brown. So this is what we're going to talk about tonight. We're going to talk about what a static website is. We're going to talk a little bit about how we interact with things over the internet using REST, the invoke REST method. And then the final thing is we're going to talk about what is an actual Azure function. And then once we learn about what each three of these pieces are, we'll glue them all together and take a look at the web app that I created and see how they all work with each other as we work through. So there are things that we can do much better than what I've built, right? This is, again, personal stuff, proof of concept. I'm doing it on the cheap, trying to save some coin. So if you have cloud experience, you're going to look at some of this and probably say, well, you would never want to do it that way. So, and I completely agree with you. You never would. But since I'm just building something to learn it and to kind of proof of concept it and show you what it is, this isn't going to be the enterprise scale of what we can do in serverless. This is just some cool stuff that you can do to get you started. So the first thing we want to talk about is, what is a static website? So in Azure, we've got things like app service plans that you would use at enterprise scale to host your website or web service out of. So you don't need to do that, though. So a storage account is like the protein of anything in Azure, because everything's back-ended with storage. So whatever you're going to be saving or reading from needs a storage account. That storage account has an option to provide a website straight off of it. So you don't get the benefits of like having a pretty name, and you don't get some of, like that enterprise scale where it can scale up or scale out to support you as well. But for just something to play around on, make a storage account, throw some blob storage, some files in blob storage, boom, website. It's that easy. It's not really hard to do. And so that's what we're going to use today. And that's kind of the idea behind a static website. So the static website serves code out of a hard-coded container called $web in that storage account's blob container. So this is going to be the foundation for how we interact with our serverless architecture, right? So think of the website as the GUI, right? Before you would use your console and you would have a console app and 1, 2, 3, 4, 1, 2, 3, 4 as you work your way through the menu, or you could go in and build, a Windows presentation framework or call .NET directly, or there's many ways that we could go through and create a way for a user to interact with the functional code on the back. So the website's what we're going to use for that. So you're going to build you a simple website that gives a couple inputs and a couple buttons, and then that information is what will get passed in to your Azure functions and then return data back to the website to give the user what they want, right? That's all it is. So the static website is this really simple and easy thing that we're going to use to generate the GUI that's going to interact with the Azure functions on the back end. So the next thing we want to take a look at then is the REST APIs. So REST APIs stand for representational state transfer. So they'll always use methods like get, post, put, delete, update, right? There's a few of them out there. The thing that's important to know about REST is REST isn't consistent among everything, but it's consistent among that service. So there's never a time where I have found I get to interact with one web service and then go to another one and get to do the exact same stuff to get my data. There's always uniqueness to that, right? So you're going to be reading a lot of documentation anytime you're moving and interacting with some other web service. For your own applications that you put in Azure functions, it'll be the same thing. So you're creating the interface with which people are going to pass data to it. And that could be your own static website as its own GUI, or it could be that you're creating something more open and free that other people might want to interact with to get data from. In which case, you don't necessarily need the static website. You're just going to have a bunch of Azure functions that other people interact with. So when you're building it, you want to make sure that you have consistency in mind. So the way that people interact with your data across that entire service, that app service, needs to be using the same verbs, the same format and structure, returning data the same way, things like that. And when you interact with others, you can expect that same thing. So as you read the documentation about that app service and you learn about how it expects to get data or receive data from you, you can continue to expand that across the rest of that service, right? So for us, we're going to do this interactively. We're going to do this interactively using invoke REST method and take a look at just how we can mess around with an API and get data back in a way that we expect to get data back and play with it as an actual object, right? So that's what we're going to take a look at here. Then the final thing is, what is an Azure function? So the Azure function is a small piece of code. It's triggered by a specific event. So you construct it the same way you would locally, and then it gives data out to whatever you're looking for. My audio is not good. Is anybody else having trouble with my audio?
No, I think you're good.
You sound awesome, brother.
Yeah, you sound pretty good.
All right, cool. So that's kind of the idea, right? So we're gonna just, it's an Azure function is no different than building a function on your local computer. The same way that you would make something today that, go interact, a function that goes to interact with Active Directory, or a function that goes to interact with Exchange, or whatever else you might do. The same way that you develop that function today locally in your own modules locally, or even as a single function in its own PS1 that you just have off to the side that you use, is the exact same thing you're going to do in the cloud, right? There's no difference between those two. It's still just PowerShell. It's still running in, in a PowerShell core interpreter, and it's still going to do the exact same stuff that you would expect it to do. The only difference is that you invoke this one differently. So instead of double clicking my PS1 script or by opening PowerShell and then doing // and the name of my PS1 to get the PS1 to start running, in this instance, we're going to do something else. And those events could be many things, right? So the most common ones, and what we're going to play with today, is going to be an HTTP trigger. So I'm going to query a URI, pass it the information in the URI, and then my PowerShell function is going to go forth and do the do. So, but that could be done as a cron job. That could be done by events happening in storage, right? So URI, URL, same difference. So a URL can be a URI, Dan, but a URI cannot be a URL, right? So I always kind of default to the more generic URI term. So the URL would be like the www.google.com when you click that link and it takes you there. So that's the locator to get to the website. So a URI does not necessarily mean it is resolvable as an actual website. So think of SAML authentication. So when you go to do something like SAML, your entity ID starts with https:// whatever, right? But that's not an actual routable thing that you can use to go to a website or something like that. So it's not a real URL. That's a URI. So that's kind of side note on that one. So yeah, so we're gonna go and we're gonna, we could interact with this however we want like that. So that's kind of the Azure function side of things. So the big reveal is you've been looking at a static website this whole time. So this entire slideshow has been hosted directly out of Azure. It's just a little bit of HTML and CSS and a little bit of JavaScript. Actually, this isn't any JavaScript. This is just HTML and CSS. So we can go take a look at how that is. If we come over here and go to my web app, I have a storage account. And in that storage account, not events. So in that storage account, I have this blob containers. And in blob containers, we can see here's that $web that I was talking about. And inside $web, we'll see I have a slideshow folder. And inside slideshow, here are each of my HTML files, the background image, my expressive hamster, and some CSS to make this responsive. And you can see how that looks here. So this website is what was given to me when I turned static websites on that particular storage account. And then from there, we're just passing in the exact virtual directories across my web root. So just like you see here, from $web, I went into my slideshow folder, and then from slideshow is slide1.htm. So we can do that exact same thing right here. So, slideshow folder, slide1.htm, and boom, we're right back at the front again. So here's a perfect example of a static website. So let's go build one. So we've already made a resource group for tonight. It's RTP-SUG demos. So to make a storage account, it's really simple. We're going to come up and hit add. We're going to wait. Normally this doesn't take very long. Why is this so slow? Any questions while we wait?
Nope, but I think you're doing a good job.
Let's try it this way. See if that works. Let's try it this way. Create a resource. I think Azure may have broken.
You broke the internet.
Well, that's disappointing for an Azure talk, isn't it?
I think that's happened before.
All right, so search the marketplace. We're going to go for storage account. Yeah. Somebody reboot it. Yeah, this isn't good.
So I think at the one point, you know, it at this point you can use the GUI, but you could also use PowerShell itself, right? To create a new storage account. Oh, there we go.
All right, excellent. Yeah, so if you have the AZ module installed, you can definitely create a storage account using the PowerShell modules as well. That is true. So we're going to come through here. We're going to say create storage account. We're going to name it, or first we're going to pick the resource group we want to put that storage account into, and then we're going to name it. So RTP SUG demo 2. And we're going to choose what region that storage account lives in, and then whether or not we want to pay more money or not for our storage. So this has to do with durability of your data. So if we do locally redundant storage, then it's just going to stay in this data center in East US2. If we do zone redundant storage, then it'll stay in multiple data centers in this region. If we do geo redundant storage, then it'll go to multiple regions, right? So on and so forth as we work through. So we can just keep it right here local to us. We'll head into networking. So how do we want it to be accessed? How do we want our data to be rather accessed? And then some extra security across how it might be used. And then we can review and create and hit create. We're going to just skip the whole tags side channel and just not head down that road. So, and then that's it. And then up top, we can see right here that the deployment's in progress and we're creating a storage account. And this will take a few minutes to create that storage account. So just as they do in the cooking shows, I've already made one and we're going to use that storage account so we don't have to wait. So I've created RTP SUG demo store as my storage account here. So this is a bone stock storage account as it will be when this is done being provisioned. So in order to make a static website, all we're going to do is come down here to static website and turn it on. Switch it from enabled to disabled. So it's going to ask us what the root file is to load the website and what the 404 file path would be for if somebody goes to look for something that doesn't exist. So here we'll just type in index.html and here we can just type in 404.html and we'll say save. So in doing that, here we can see it's given us some endpoints that we can use. So this is what's going to be our website. So if we go and copy that and take a look right now, it's not going to load anything because we haven't provided any data to that location yet. So let's go fire up a new folder. Whoops, that'll work. And make us a couple files. We want to do index.html and we want to do 404.html. So we're going to make two simple files here. So in the 404, we can just do a tag for H1 that says you took a wrong turn somewhere. Right, and then under index, we can make something slightly more interesting. So we'll throw in the body tag on this one and then in the body tag.
You just zoom
Hey,
it.
Jeremy-
You want to
Jeremy.
make it bigger?
Yes, sorry, totally spaced on doing that. My bad. Is that good?
Terrible presenter, so bad.
Is that good?
Yeah,
little bit
man, that's
better.
good.
You want me to go bigger?
One more.
Boom.
Boom.
All right, so yeah, so here we'll just throw in like a, well, let's throw in a title.
So while you're doing this, Dan was wondering, these files that you're writing, are you writing directly to that blob storage, or is this local and then you have to sync it up?
That one. So right now I'm just, I made a folder on my C drive. So C drive, get personal. So here's that RTP SUG demo folder that we're currently in right here. So with my index and my 404 in it. And then once we make the data, once we make our files here, we'll upload those files into the blob contain that $web container in the blob storage of that storage account.
Now,
So
is that
anytime,
a convenience thing? Like, could you edit on the Azure side directly?
let's check and see. I'm not 100%. Things change so much. I'm not sure right now. So that we can go. Well, I mean, I guess the answer to that is 100% yes, because if nothing else, I could use the cloud shell, the Azure PowerShell in the cloud to edit this with the Azure VS Code thing. Yeah.
Yep.
So we could totally do this in the cloud directly if you wanted to, but you'd lose a lot of the VS Code functionality. All right, yeah, so that's good. We can just save that. All right, so now I've got my 404 and I've got my index.html. So here we're just going to go ahead and deploy this to a static website. Now I should say this is coming from, how do I get to my stuff now that it's so big? A few extensions. So this Azure storage extension is what I'm using to interact with my storage accounts in Azure through VS Code locally on my box, right? So that's how we're getting to what I'm about to do now. So again, let's take a look real fast. So if we come over here into Storage Explorer for my static website, because I've enabled static websites, I will now have a $web container, but my container is going to have nothing in it. Now we're going to come over here. We're going to deploy my static website. VS Code is going to ask me to pick a storage account. So we'll pick the storage account that we just turned Azure, the static website on for. You see it's already done. That took no time at all. And then if we come back over to, if we come back over to here and we refresh,
I think it was also, yeah, you could also, there are also technically other tools, and like Brett's mentioning is Storage Explorer and stuff.
Yep.
So you could do like a file copy kind of stuff, but
So,
using VS Code is a lot simpler.
Yeah, absolutely. So there's Azure Storage Explorer as a thick app, which is what's been around for quite some time. And then they've just moved this functionality directly into the web portal. So if you come to the storage account, you'll see Storage Explorer here, and they look almost identical. So the way that you would have done it inside your Storage Explorer and the thick app, you can do in the portal as well. So let's let that.
So not stuck in VS Code. If you're not comfortable writing HTML for some reason, and you have some tool to create HTML, you're just grabbing files after they're completed.
And then Brett says are you saying the thick app is slow, Brett?
Yeah, I've got 32 subscriptions. So I've got to filter out the subscriptions I don't want in there if I'm searching for something specific. So it's awful with that many. You have to reduce the amount of subscriptions you've got active before you can then start filtering through storage accounts and things. It's
noted. I have never gone more than 2, so I haven't had those problems. So here we can see it's been uploaded, right? So the data that we just saved got put up inside this $web container. And if we look in the thick app, so we can go down to here. Oh, wrong one. Here, and then here. And we'll see the same data here. And as you can see, the interface looks very similar to what you would have seen in the website. I've pretty much quit using this. In fact, I'm glad you said something because I straight forgot to even open the thick app up since this has worked great for me for anything I've wanted to do in interacting with storage accounts this way. So yeah, I don't see an ability to edit through the Storage Explorer. So to answer the question about can we do this all inside the cloud, you could, but you definitely have to come up and use PowerShell for that. There wouldn't be a way to open it up and edit inside the browser here. All right, so now that we have content there, if we come and refresh this, boom. So we can see the title's been set up here. We have our header right here. We can go add in anything we want. Somebody name a picture to search for, keep it clean.
Donuts.
Donuts. I'm gonna go with Brett's. What? So we'll just grab a picture here from something.
Keeping it respectable. Come on now.
So, and then we can just throw that inside of here as well, right? So we'll throw us an image tag on this. See if I can get this right off the top. I think that's all I need, right? Did I do it right? Let's find out. And then choose our storage. Because we made a change, it's going to delete and recreate everything inside that static website. So when we upload this, whatever was there is gone, and this is the new data. If we come over and we refresh, wow, massive size. Probably should throw some inline styles, right?
That's what
but
you
you
get
get
for following Brett.
Yeah. So it's just, look at that face. So anyway,
the donuts wouldn't have been so big.
So this is the idea behind static websites, right? So the goal here that I want everybody to see is that it's very, very little upfront effort. Make a storage container, throw some content in this $web after you turn it on, boom, website. So you can get way more involved than what we just did. So, and in fact, the app that I have that we'll see at the end, it's got a whole bunch of JavaScript behind it in order to create that dynamic feel, in order to interact with those functions and move forward. And we'll take a look at that at the end. But right now, I just want everybody to see how a static website, how you interact with it and how it's used. Everybody feel good with a static website?
Good to go.
All right, cool. All right, so the next thing we want to take a look at then is the invoke REST method stuff. So like I was saying before, everything that you look at is going to have its own way to interact with it. So we're going to pick on I can has dad joke for this one. And what I want to show you is, so I can get a dad joke just by using invoke-rest method and then passing the same thing to that, right? So boom. So except this doesn't look like we want it to look, does it? And you probably want that bigger. Nope, not like that, you won't. Let me just do this. Boom, boom, boom. All right. Yeah, so is that big enough? Everybody still see that all right?
Good.
All right. So invoke REST method. So we can get all that same data here, and we haven't looked at anything yet. We're just kicking off invoke REST method straight into the base website, and we get back a whole bunch of HTML data. So which if we went over and did view source, it would look exactly the same. And in fact, inside of here, we can still see the joke somewhere. I feel like it's somewhere in this area. Boom. So here's the joke. If I had gone directly to the website, that would have loaded at this location right here, right? But this isn't very useful. Like you could get this data and then try to cast it and then break it apart, or use the world's worst regex ever in order to find the joke and then pull the joke out. But I can has that joke gives you a way to interact with it programmatically. So if we go over and take a look at its API documentation, it tells you how to go interact with it and get your data back. So first thing, no authentication, which means that I don't have to go enroll and get an access token and then hold that access token and supply that when I get it. I can just pass the call directly in unauthenticated and it'll give me data back. The second thing we look at is this API response format. So the default is to give us HTML content. So the reason we just got all of this trash essentially inside our invoke REST method is because we asked for that. Since all we said was invoke REST method with nothing else, it defaulted to text HTML as its response back to us and gave us the HTML website. If instead we had asked for JSON data, then PowerShell could have taken that JSON data and turned it into an object for us right off the start. Well, that sounds really awesome and way easier to interact with the data. So how do we do that? So we need to use this accept key in our header and then pass the value application/JSON in that key. For invoke REST method or anything PowerShell wise, that's just a hash table. So we'll make us a hash table. Header equals at accept equals application JSON. Boom, right? That's it. So, and it's just a hash table. So, you know, if I had other things that I wanted to put in here, we could put other things in here. So, you know, like my name, for instance. This would be a terrible idea for most things, probably. Wrong one. That one would be the comma, right? So now, if we take a look, I just have a hash table. Over here, I've got my keys. Over here, I have my values. So this is the first thing that your documentation for whatever web service you're interacting with is going to tell you what to do. So for however you want to consume the data, for things that you might need in order to authenticate, you'll have different keys that you have to add in and then pass an appropriate value from that key. In this one, we only need this accept in there. So let me go ahead and remove fname so that my header looks like that, right? And now if I go back to invoke REST method, pass in the same URI as before. That's a long way away. We're just going to do that from here. And then add in one more switch, which is headers, and pass in my hash table. That's all I'm going to do. We're going to hit enter. This time we get something that looks a little better, right? So this is going to give me the joke. It's going to give me an ID, and I should also see a status. If we take a look at get member, so you'll see here's my ID, my joke, and then the status with a status of 200, which is an HTTP callback to me to let me know that it was successful. And because this is coming back as JSON data that PowerShell will just turn into an object for me, you know, we put that in a variable and then just interact with it like we would any other thing, right? So if I really want the joke, I just foo.joke. Whoop. Where did it go? Oh, haha, hold on. It helps if you ask for the joke and not the the membership, right? There we go. So now foo.joke, and I get only the joke passed back out of the JSON data that was returned to me from ICANN has dad joke.
Cool.
So that's kind of how we're going to interact with something over the web.
So question there is that assuming that they had an API and they published an API so you could find it, but otherwise you could play this game of trying to parse something.
Yeah, you could. If somebody's got something for you to work with on the web, they're going to have some documentation for it. Sometimes it might be I have to log into a portal to go get it and it's not publicly available, but they're going to have some sort of documentation. It's possible to like reverse engineer something and be able to interact, but That is well outside the scope of a welcome to your first serverless.
But it's a good idea at this point, kind of like you saw the whole JSON thing, and say, hey, if I can try and get a JSON object out of it, then hey, I can try and see what happens and do some
Oh
discovery.
yeah, absolutely. Yeah, and I'll say like application/JSON is a very common, except application JSON is a very common header. So that's one that you could probably pass in and just give it a shot and see what happens and succeed quite often. So, but some of the rest of like when you're, we're picking something really easy to do here. So sometimes your REST method's going to pass in a bunch of variables as well. So just like you would in your function that you made locally, right? I need to know all these different things in order to make the code go work. So you'll do that same thing. So your URI is going to have a question mark, variable equals, and variable equals, and variable equals all the way across it. And so if you don't, and just like your function, some of those are mandatory, some of those aren't. And so if you don't know what it is you're using and how to pass the data that it needs to function, that it's more than just the header. A lot of times, I guess is what I'm saying.
The other thing I would say is that websites these days are very often run by content management systems, WordPress and Ghost, and things like that. And if you do, if you try to browse the code and not look at the API, oh my God, it's impossible to try to figure out where the data actually lives. And trying to pick that apart with regex, like Jeremy said, or someone else, this is way easier. Way easier.
So, everybody cool REST method? Is that identical to using the content type parameter? I'm not sure what that is, Jeremy. Let's go Google that.
Yeah, you can pass it in as a header key value pair, or you can use content type parameter of invoke REST method. It does the same thing.
Yep. Okay. All right. Don't need that either. Is there a PowerShell equivalent to Python's beautiful soup model? Not that I'm afraid of, or not that I'm aware of, Jason. Although I don't know that we really need beautiful soup, because if you use invoke web request, you can bring that down and then it will kind of do beautiful soup on its own. So you can notate your way through the web content to whatever it is that you're looking for. So it's close, but it's not quite the same. Yes, sir. All right, so that's kind of the second part, right? So now we know about how we make this website that we can use to capture data and then pass data into a function. And we now know how we're going to interact with web data to some capacity, right? So the last thing we want to take a look at then is, what does an Azure function look like? So first thing we want to do is we want to go build one. So I'm going to come into RTP Sug Demos and I'm going to try it with the way I like to do it. And this is working much faster now. So we'll hit that. Let me try that again. That was really fast. So from your portal, there's many ways that you could do it. You could search from here. You could hit create resource. I always like to go into the resource group that I'm creating something in. That way I've previously before forgotten to hit a drop down somewhere when you're working in the portal, and then you end up making something in a place you didn't intend for it to be. So if I go into my resource group and I hit add from here, it'll pre-populate a lot of the drop downs so that I know it shows up in this location. So that's why I prefer to do it this way. So from the resource group, add, and then we're going to choose function app. So this is going to make me an Azure function. So we'll give it a name. So RTP Sug Demo 2. So we're going to give it a runtime stack. So these are all the ways that we can execute code for an Azure function. We're going to use PowerShell core for that. And then we're going to give it a region. Right now, PowerShell 6 is still the only one. 7's coming. So soon we should expect to see a new drop down here as well. And then we're going to move on. So your functions are PowerShell scripts and JSON files. So those need to be stored somewhere in the cloud. By default, it's going to make its own storage account to hold that data. You can let that happen, or since we already have a storage account that's going to interact with the same data, I'm going to choose to save myself an extra storage account and just use the storage account that's holding the static website as well. There's reasons why you may or may not want to do that. So I may want to keep this code separate from what's being publicly served. And if that were the case, then I would need 2 different storage accounts for that. When you start to separate your data that way, though, the complexity and the security behind how the website and the apps interact can be a little more difficult. So when starting out, I would definitely encourage you to make sure that you create your app service in the same storage account that you're making your static website. So down here is where we're going to choose how expensive our serverless is going to be. We want to go with consumption based. Consumption is the one where you're paying per cents of a penny for the amount of time that it runs. So, and it's going to run just fine for anything that you're probably interested in doing. Most of the, like, I think it's an hour is how long it stays up for, and then the your stack will be disposed of. So if you're giving out calls once an hour, then it'll be snappy fast. But if you wait long enough, it'll throw it away. So the next time you go to make a call, the very first one's going to take some time because it has to go build a stack that's going to, basically be PowerShell running inside its own container, and then your code executes inside that container. So you have to wait on it to stand that up before it runs your code. After that, though, it'll keep it running for a while. So as you execute more, all the rest of it will be very snappy. If you were looking for something enterprise, that's when you would move to one of these, because these are where we're gonna actually keep something running all the time. And this is where we'll get to start choosing how we want to scale it so that it can scale larger if we saw high demand on whatever it is that we're building. But for us, we're making something derpy. We're going to stick with consumption based. Monitoring. This will let you see who queried when, whether it's successful, stuff like that. I'm not going to bother with turning monitoring on, and then we're going to go ahead and create that. So that, again, just like before, this can take some time. This will take much longer than the storage account to get created. And here we just wait. So while that runs, we're going to take the lesson from the cooking show once again. I've already created an Azure Function Service App right here. So let's go take a look at how we interact with Azure Functions. So once the app gets made, this is what it'll look like. So this is a blank, nothing done yet to it. So tonight we're going to stick with doing everything inside this web console. So the easiest way to get started is use the portal. The portal makes a lot of decisions for you that you otherwise wouldn't know to make right from the start. So just to see some success and start to learn it, if you use the portal, when you go to make choices, it'll be like, well, you have these dependencies. Let me go ahead and configure them for you. If you're doing this inside VS Code, then you're configuring JSON on your own, and you'll have to just read the error and then go make changes accordingly to the JSON. And it might not be the same file, right? So you could have to make changes in the platform or in a different function for what it's reading in or reading out, things like that. So to start with, I would encourage you to stick with just making simple things in the portal. So you can always build, remember, the function is no different. So you can always come in here, you can always build your functions locally and get them to work, right? So the functions for my app exist right inside of here. And I can run these functions without, oh, that's why. So I can run these functions without needing to go out and grab Azure function stuff. Copy this, pass the data in, see it work. Once it works, all I got to do is copy and paste that into the web portal, and I'm ready to go. So let's make us our first function. So we're going to come in, we're going to choose to do this function in the portal, and we're going to choose a webhook API. So this is the essential hello world kind of thing for the Azure function. Here we'll see that it's bringing in and looking for a parameter called name. And it first checks to see if that's in the query. And if it's not, then it checks to see if it's in the body. And if there's a parameter called name in the body, then it will store whatever that value is in a variable called name and then return that to us. As long as something name is there, it'll return back status code is okay, and in the body we'll return back hello and then whatever we passed in the name. If name isn't there, then we'll get the status code of a bad request, and in the body it'll tell us we did something wrong and need to do that differently, right? So this is the entire function, and then the actionable part of this function, what gets it to us, is this push output binding. So in PowerShell with Azure functions, you'll use these output bindings a whole lot. So this is where we determine what we're sending it to and what data we're sending for that. That's a pretty terrible description. Let's go take a look at what that means. So in this particular function, we're pushing our output binding to this binding called name, or binding called response. So if we come here, we can see in outputs, there's a binding right here called response. See that? So this is how we know what we're doing. So there's an HTTP output binding called response, and that is what we're using to determine what to send to. This is what that JSON looks like for that binding. So what is that? Oh wait, hold on, come back. The other thing I wanted to show you real quick was the authorization level. We're going to go ahead and flip that over to anonymous for the moment. So this is the security that we're going to set on the Azure function. By setting it to anonymous, anybody can run this Azure function. Whereas if I have it set to function, then I need an access key, an access token, in order to be able to run the function from somewhere else on the web. And then whoever knows that is who would be able to run it. So typically you would leave this to have some sort of security on it, and then you might store that in an Azure Key Vault or something like that, and then read out the security key to execute the function. But for tonight, we're sticking with easy peasy lemon squeezy, and we're going to go with anonymous. So let's use the current hello world that we have right here. So we're going to get the function URL. We're going to copy that. We're just going to come up here and we're going to paste it and go. And like I said, that first one takes a second, right? Because it's got to stand everything up in order for it to go, you didn't pass the appropriate variable, and then give me back an error. So now we watch the pot boil water. How's everybody feeling? Any questions?
So
I
maybe-
have a
maybe-
question, but I will ask you at the end of this.
Okay.
That was Victor.
Yep, that was me.
Okay, Victor, we'll come back to you. I was just going to say that it probably is worth mentioning. This all can be sped up, right? It's just a function of spend. So, as you said, doing this on the cheap just for demo, we're okay with this right now. This obviously would not be acceptable in a real world situation, and Azure has ways around that.
So what you generally find on the consumption plan is you've got cold start. And also, when you first deploy your function, it has to download the managed dependencies to the host. So it'll sit for a long time and on managed dependencies downloading. And then the second time you run it, it's immediate.
Yep.
But even on the cold start, after the first initial run, when you've deployed it, it's a lot quicker. But cold starts are only really an issue if you're using the consumption plan. If you go start looking at the app service plans or the pre-warmed instances, it's a lot better.
Yeah, all this goes away. Although normally it doesn't take this long.
You didn't connect to the logs quick enough.
Yeah.
Cold start I've seen vary. 42, yeah. I've seen vary up to 5 minutes, but it's generally a lot quicker than that. Like
Yeah,
I said,
normally it's
when you
a minute or two.
first run this, it's downloading the managed dependencies.
Yep.
So it's returned there. If you run that
There it
again, it'll
goes.
be immediate, won't it? So
Yep. So from here on out, we're going to be good to go on this as we run it. And that's a pretty long one. Normally it doesn't take that long. All right, so like we were taking a look at here, right? So it's expecting something called name in order to get data back. Because we didn't pass name, right? See, there's no name in this. Since we didn't pass name, it told us that we need to pass name on the query string or in the request body. So let's do that. Let's do what it asked us to do. So we can come in here and say name equal Mike Kanakis. Right?
Famous, Mike.
So now that we've met the minimum requirements for this function, it goes and does exactly what we asked it to do. So from here, we can do whatever we want. All you got to do is come in and start playing around and changing stuff. And that'd be the easiest way to start this, right? So let's say that we're only going to take it straight off the query string or the URL, right? And then now, as long as we have something in there, and let's call this something different. Let's call it value1. And we'll call this value1. And then let's just make another one, value2 equals, and then we'll copy, paste, make that value2. That's probably better, right? All right, so now here we are. We've got two different variables that we're expecting to see. If value1 and value2, then let's give back some extra, something different. So we'll say value1 plus value2 equals one. These are going to come in as strings, so we should probably cast them as ints. Actually, I'm not going to do that. Let's run it like this first. All right, so here we've completely changed this up into something totally different now. Right? Completely something different here. So we'll go ahead and save that. And then come back over here. If we run this with nothing, we see our new error. And if we pass in some data, so value1 equals 23 and value2 equals 45. Hit enter. Oh, cool. It actually did it. 23 plus 45 equals, oh no, it didn't. There you go. See, because what it brings in, it reads in as a string. So it's going to take our two numbers and it's going to concatenate them into 2, 3, 4, 5, right? So, which is not what we intended. We were trying to make a dumb calculator. So let's cast these as int once they get read in. And then let's go rerun that. This time it works like we expected it to. See how that works?
You want to zoom in your Google
Dang
Chrome?
it. I'm so sorry, guys. Do you guys want me to redo that just so you can see it?
I think it looks good.
So if we come over here and we run it this way, because we're not casting these values, they're going to be read in a string. And so since they're read in a string, that's 2, 3 as a string plus 4, 5 as a string, which concatenates them together, which is not what we expected. So by coming in here and then casting them as int, we turn those string things into int things. Yes, Stephen, query values will always be read in a string data. So afterwards, you'll have to take it and do what you want to with it after the fact. And now we're returning our data as we expected it to. So this is an HTTP trigger, really straightforward. I think it's probably the easiest way to interact with data. And the cool thing is because we now have this thing here that we can do stuff with, we can also take that and throw that into something like this. And get data back. Pretty cool, right?
Yep.
See, if we weren't remote, I'd see all kinds of jaws on tables right now and deep gasping breaths.
Wait.
So that's kind of the idea, right? So this is the basic situation. Static website is our input values, interacts with the Azure function. It's going to be the thing that's sending us our data like this, and then returning data back to us. And then we will take that data and then output it back on the static website. And you just keep going back and forth. We talked about some of the security stuff already. We talked about how all of this works. So one thing I would like to show you is if we come back over and we take a look. Remember I said there were lots of different ways that we could invoke an Azure function. I'd like to show you what that looks like.
So I think at this point you're also limited to whatever the script is going to do. So you kind of said, hey, took in some input and rewrote back that out to the current page itself. But you could have reached into some other pages, reached into some data sources, done some other work. Effectively, it's whatever your mind can think of.
Yep, absolutely. And that's actually exactly what we're going to look at the end of this here in a minute, because as I stated in the beginning, I wrote something that I could have just Googled. So that's exactly what I did. I just built the middleman. So where I could have just used PowerShell and interacted with the NOAA interface directly, I built an Azure function in the middle. So I interact with my Azure function. My Azure function interacts with the NOAA API and then returns back the data. So that's exactly what I made just to go learn how Azure functions work. So like I was saying, there's tons of things, right? So HTTP is what we just took a look at and played with. Timer triggers or cron jobs. So you've got queue storage, bus queues for event data. Here's that Azure blob storage that I mentioned earlier. Database triggers, service bus, everything. There's all kinds of stuff inside of here. And then you can also build your own for setting up some sort of way to invoke an Azure function. So pretty cool, right? All right, so let's take a look at what I made. So now that we've seen kind of what's required for all of the different pieces to work, if we come take a look at my Derpy web app, we can see I have a storage account, and my storage account has a static website turned on. And in my static website, I have a JavaScript file, an index file, and then just a blank 404, just something that says 404 on it, nothing else. That code looks like this. So I don't have a whole lot of data inside my HTML file for index. So just a little bit of data here to give me a title. So I have a header, I have a dropdown, and then I have a submit button, and that's it. So my functions.js is really where the meat of this all happens, right? So here I have a bunch of different functions that are providing different data on the page, right? And this is what's interacting with the Azure functions. And my Azure functions look like, whoop, I was in the right spot. My Azure functions look like this. I have two of them. One of them is the thing that actually goes and gets the data. And one of those is a thing that I use so that the website's a little faster. So the get water temp is the meat of the website. This is the one that's going out and doing what I want. So my derpy web app will go out and tell me how cold the water is around the coastal United States. That's what my derpy web app will do. So I will use my website to pass in the station ID from the dropdown to my derpy web apps URI here, where station ID equals whatever that value is. That gets read into this function. So here we can see that station ID is the parameter. So I take that, I pass that into this longer URI right here, which carries in all of the things that are required in order for me to get valuable data back. Notice that they return data as CSV data. And then I take that CSV data and turn it back into an object, take the object. They don't give us to it in American temperatures. So I have to convert that back to America. And then I pass that data back out. So all of the data comes in as Celsius. So we do some math on it, send it out. How does that work? Like this. So here's the website. Here's the dropdown. How cold is it in Wilmington? Hit the submit button. Wait a little bit. Boom. 5905. We could head over to, I don't know. Let's go, yeah, we'll go to Point Reyes, California. Currently it's 54.5 degrees in Point Reyes, California. Fort Pierce, Florida, probably be a little warmer there, 75 degrees, right?
So is
in
it
all
doing a pull? You're doing this work, and it's doing another pull back to that. So, or is it gathering all the data, or just doing that one?
So, yeah. No. How do I turn this off? I don't remember how to turn off.
Drag the bar on the right-hand side of the window.
Ah, thank you. All right. Yeah, so like here, we'll do another one real quick. Let's go back to Wilmington and hit submit. So here you can see when I did that, right? So hit that drop down again, go grab Fort Pierce this time, hit submit. So my station ID is changing. See that? So I'm running the get water temp function and passing in station ID equals into my get water temp function. Does that make sense?
Yep.
So, and then this is, where's it at? Oh, hold on. Well, anyway, it's sitting in here. It's what it is. It's actually.
So it's dynamically pulling from a different website. So instead of having you going to NOAA and getting all that detail, you're just saying, hey, go pull that individual piece of data. But also you're not pulling all the water temperatures and then basically just filtering at that point. So it's based upon what that is doing right there.
Yep.
There you go. There's your code.
Yep. So I'm just passing in station ID to my Azure function and getting the data back for that one thing.
It's then reaching out to that API, then parsing the data and just pulling back just the pieces that you want.
Yep. And you can see, like, even here, when I get data, I'm getting more data than I want. So here I have to take what they return to me, because really I only want this one particular property. So it's returning back to me a CSV file. And then I take that CSV data and read that in, and then pull just that one column or that one property out of that, all of the data it gives me. Do some math, round it, send it back out.
So it's being called by the JSON that so the JSON is calling the Azure function. The Azure function's then reaching out to Noah. Noah's then returning the Azure function, then returning back the data into the body.
Absolutely. So
Okay.
right here in my HTML, I have a submit button that is going to pass in the station ID from my dropdown. Right. So, and then that is attached to, if we look down here, so I have an event listener for that submit button to run this update web page function. The update web page function has this thing here where I read in the input value into this import forms and then pass that station ID dot value into the get station data function, which is this right here. So this is the thing that actually goes out and calls my Azure function. So this is a whole bunch of web programming kind of stuff. The part that's important for the Azure function is this piece of code here. So essentially I'm taking the station ID off of the dropdown and passing it in to my Azure function, which is cleaner and prettier and lets my Azure function have the nastier information in it. So I've basically built an API front end for Noah for this service.
Cool.
Tommy, what about line 23?
No, Stephen was asking where's the get station data called. I was saying it's line 23.
Ah,
Right there.
okay. So get station data is a little different. And I kind of saved that one for now. So when I first made this, I ran into a problem, right? And that problem is when you first load this, right, it takes time for everything to stand up. So with it taking time for everything to stand up, if this was an Azure function, it would be an empty dropdown, and I would have to wait. Seconds or minutes in order for that to start up, and then I would end up having to reload the page before this would populate with something. So anybody that came here would just think it was broke and it didn't work at all. So I needed a way to read this data in when the page loads. And then afterwards, when they hit the submit button, that's when they get to think it's broken. Right?
Interesting. Yeah.
So how did I solve that problem? Well, I solved it with an Azure function. So I have a separate function here called get coastal stations. And get coastal stations takes this array of buoys that are around the coastal United States, and it reads them through and grabs the data for those buoys here. So if those data are valid, then I create an object of the ID and the name and send it out. So once I have all of my data compiled into this coastal stations variable, I convert that to JSON and then I output that. So if we take a look here, you can see my output binding for this one is not an HTTP trigger, it's Azure Blob Storage. And since it's a timer trigger, I'm giving this a cron schedule instead of an HTTP trigger. So every single day at 7 o'clock in the morning, this Azure function turns on and fires. Nobody has to do anything for it every morning. And what that means is every morning I will get a list of the stations that were currently up at that time. Because I found that some stations would be up one day and then down the next day, or down for a few days and then back up again. And since we don't know what stations are valid and what stations weren't, this function will go through and determine which ones are good. And I'm just assuming that for the next 24 hours, it'll be good. And then populate a JSON file with that. If we take a look at the output of it, every day at 7 o'clock in the morning, my push output binding, name output blob, the value is that JSON data, and then I'm writing that to this path right here in this storage account. Does that make sense? So this is
so
how
effectively you're running this new Azure function to actually, on a schedule, just generate some data and then dump it into some JSON file. Then
Yep.
later on, your web app is actually using that JSON file to build its other list from there.
Yep, exactly. So here's the code that makes my array of station ID and name. I convert it to JSON, and then I use the same push output binding that we saw for the HTTP trigger. I give it the name of the current output binding, which is that output blob this time, and the data is just a big bunch of JSON data. And because this output name, output blob is blob storage stuff, then it'll use that to write a file with the values that I put in there into this storage account. And we can take a look at how that looks, right? So if we come into resource groups, and we go to my Derpy web app, and we take a look at my storage account. So in here, my path is uploads, and then the file is coastalstations.json, right? So in here, under blob containers, there's an uploads folder, and in uploads, there's a coastalstations.json. And so every day, this gets updated if it needs to at 7 o'clock in the morning. So now, in my code, I have get stations. And this code will go out and grab that JSON file from the URL that I provide down here. So every time the page loads, right? So here's me defining a bunch of functions. And then, just like in PowerShell, right? You make all your functions first, and then the code that runs after that. So here's that code that runs after that. So every time the page loads, it runs this get stations at this URI and pulls down that JSON file, and then takes that JSON file and builds my dropdown dynamically. So that way, every time you go to this website, you hit this button, and sometimes you'll actually see this be a little slow, and this will be a small thing for just a second, and then it expands out as it builds out all of the current stations that are available for me to get a temperature off of. So here I'm using a different type of Azure function to serve the same app service where a cron job's running every single morning to give me that data. So every time the page loads, my dropdown is populated. And since all I need is name and ID, that's all I carry in my JSON. I could have done more data than that, but I didn't. I just chose not to, right? So we're populating text in my dropdown, and we're populating, or we're capturing value in when we hit the submit button.
I think it's very informative, the idea that you're using different methods to create your Azure functions, which are effectively just PowerShell. One method is to generate, so basically download content and put it into a format that you're going to use later on. And the other one is basically to then use some of that data to then reach out to other places and do more work and effectively return new data. So I think it's just really interesting. So thanks.
Yeah, and the beauty of it is if you can have as many functions as you like within a function app.
Yep.
You only get the cold start once for that function app, and you can use all of the functions within there. So I've done
that's interesting.
Yeah. So the one function app has to spin up on a specific host, but all of those functions are loaded at that runtime. So you can have 7 or 8 different functions within a function app. When the first execution is done, it loads everything on the host. You can then use all of those functions and interact with all of them. So I've done something similar where I've got a Teams webhook which calls a function, which drops a message onto a queue, which triggers another function, which spins up an Azure container instance from ACR. It takes parameters all the way from Teams through the queue to the next function, and then it exports a SQL database inside the container, copies that to a storage account and then passes the information back to teams to say this is where your backpack for your SQL database is. And that's chaining all those functions together, but without chaining them, because when you start chaining functions, you have to wait for the last one to finish before when you've called the first one. So by using things like blob storage and Azure in storage queues or service bus queues, the first function finishes, so it's not long running, so you're not paying for it. But then it triggers another function, which then, so you haven't got this long running execution of 6 functions all waiting for the next function in line. You're just dropping messages onto a queue, which then interact with other parts of the chain.
Yep, absolutely.
And it's effectively free because, like you said, Jeremy, like you literally pay for the execution time. So if you've got quick interactions, the functions are running for less than a minute, so you're paying for nothing. The only thing,
since you're running a bunch of functions, each one of them costs nothing.
yeah. So the only part, the main part in running something like this is the storage account, which costs next to nothing anyway because you don't have much in it.
Absolutely.
The most expensive part in mine is spinning up the container, which does the SQL backup, because that runs for say 30 minutes. But even then, it's only spun up when it needs. So I'm not paying for any long running processes like a VM sitting doing something. It just spins it up when it needs it. So the cost is minimal.
And then the cold start time is just a matter of like the fact that if it cold start and then it's just going to stay dormant for like say an hour or something. So if you call it once an hour, it'll never cold start again.
Yeah, well, I've done some funky stuff where I've basically put a function app I've put a function inside the function app with a 5-minute timer trigger, so it just runs every 5 minutes. Because with the consumption plan, you get 1 million executions, I think, a month.
Yeah,
which is free. So as long as that's constantly going on a timer, it's going to keep your function warm. So it's kind of tricking the system a little bit, but
cool. So Stephen was asking about debugging and stuff.
So I was going to come back. So Stephen, the debugging in the portal, not really there. But anything that you're building in VS Code, you have everything that you would have normally at your disposal for debugging in VS Code still. So write your code in VS Code, make your function and use it in VS Code. And then once you have something that works that you like, then you can bring that up into the Azure function in the portal. That would be my suggestion for dipping your toes in and getting started. As you get further into this, so you know what you're really going to end up looking for is this Azure Functions extension. So, and this will actually let you run your Azure functions locally against localhost and test it as it would inside Azure function, the Azure function in the portal, and let you debug that way. But again, there's a lot more prerequisites, and the movement between using the portal and VS Code isn't a very simple or easy thing. So really, if you're going to go the VS Code route, you kind of need to like dive in and do it all that way. So from the start, I would suggest looking at using the portal more, like I said, because when you go in, for instance, to build that, well, I already took it out. When you go in to build that, those output blobs or whatever your output bindings are going to be, rather, you need to know how all of that's going to link up with each other, and you might need to be making changes in a few different JSON files. By doing it in here, it'll fix it all for you. And when you're starting and dipping your toe in it, there's not going to be many things where you have to write it in the portal directly in order for it to work, probably. So that's my long answer to that question. I hope that was good enough. If not, fire something in the chat and we'll answer that too. So David, you asked a question about using consumption and keeping it alive. Yeah, let's do it, man. You have something that calls every 45 minutes and keeps it up. That's just going to go to part of your executions. So, however often you're running that cron, it's going to subtract from the total number of executions you're going to get in the free mode. But that'll keep it running. As long as you're continuing to query it, it'll keep it running. And you're still going to add a little extra cost as well, because everything is quote unquote essentially free, right? So you're still being charged money for these. It's just you're being charged so little on that execution time that it doesn't ever make it up to a penny. But if you started cronning your queries up and letting those run on a regular basis, all of those 0.001s are going to eventually turn into a 0.01 or a 0.1. So it's not like you're going to break the bank still, but you could turn a free app into a 10-cent app if you croned it up. Yeah, like I said, Jason, it's totally available. Jason was saying something about not having luck with the Azure Functions VS Code extension. There's a bunch of things that you need to do to get that to work. There's more prerequisites to get the PowerShell stuff in Azure Functions to work than there is for something like Python or .NET or C#. So you need to make sure that you have all the appropriate prerequisites in place. Otherwise, you're going to run into some errors. Absolutely. And then, like Brett was saying, it's super cheap, and I wanted to kind of finish on, like I promised you. Here's my invoices for the last year. So I don't really delete things out of Azure. Like this entire app that you're looking at's been here for, I don't know, 6 months. So, and you can see in that 6 months, we still have 0 cents in some of those time frames. So my biggest month so far has been $1.39, and that was last month. And I actually did run some VMs during that time. So if you're aggressive with making sure you delete things that you're no longer using, and you stay mostly at the platform level or higher, I'm telling you, man, Azure's super cheap. Don't be afraid of it. Go in there, start playing. So, and if you head into budgets, you can always come in and set a billing cap that will ensure you don't spend more than you're willing to spend that month. So here you can see I have a budget of $200 set on my subscription. So for my entire subscription, so here's where you can, so if you wanted to set a budget for different things, I'll let my storage go this much and my VMs go this much and yada yada, then this is where you would scope that data out. So for me, I'm just saying across the entire subscription, I don't want to spend more than $200. And so the minute $200 hits, anything that's in Azure will just shut down and stop charging me money, and it just won't work anymore until the next billing cycle. When the next billing cycle hits, everything will turn back on again. So that's my talk.
That was cool.
Is there any other questions? Steven said something.
I've got just a comment on what you just showed us about budgets. My understanding was that was just an alert only kind of thing, or not necessarily a shut it down kind of thing. Maybe it behaves differently with EA accounts versus regular pay as you go.
Maybe for the pay as you go, it'll turn them off. It'll cap you.
Oh, nice.
Mike can attest to that, right?
I have a standard MSDN account that's pay as you go, just a personal account that's got MSDN attached to it, and it's got a $150 limit, and so I set that to the cap, and I've had it hit that before and just shut off. So.
Those are different, yeah.
Yeah.
Yeah, maybe EA, there's like, just PO it, bill us.
Yeah. I could see EA being different than pay as you go. So Stephen, you asked about running against internal resources. So you can, but that internal resource will have to be accessible to the Azure function. So you would have to poke a hole in your firewall or something that says my Azure function can make it into that internal resource, or move that resource into a DMZ or something like that, or pass it through an web app proxy, or something. So you can definitely act against those resources, but there's no tunnel to work. Like your Azure function can't go through a private like VPN tunnel that you have between corporate and Azure, it's always going to be public traffic.
Well, it's unique to that resource group. So if you have some Azure resource and you can put the Azure function in the resource group that can talk to it, and so that's kind of like what you're saying. So if you're just looking for the public,
yeah.
Azure.
So as you're doing things with Azure, like that stuff can be like private. Yeah. So when I'm pushing output binding, that's not public traffic. That's internal between each of them. But if you're trying to get to I see. So maybe I interpreted that wrong. Stephen, let me know if I did. But I read internal resource as something on premises.
Yeah, I was thinking the internal resources would be on-prem, and then I also put in my comment for internal Azure resources where you've got them partitioned off for like private corporate use, and then like the way some organizations do that through their express route and their firewalls.
Yeah. So Azure Functions will never route through any of that. It's always going to be a public endpoint. So all of your security is going to have to be done with that in mind. So typically your Azure functions don't reach internally to stuff. It's just like you're going to use that for cloud stuff. So I'm actually planning to try to build another talk that's going to use an Azure function to provision VMs for people. But think of Azure functions as the duffel bag for MacGyver. He just needs the Apple core, a big pen, a little bit of tinfoil, and 6 inches of twine, right? So Azure Functions is the duffel bag that holds those things. And each of those 4 things that MacGyver needs is a unique function in there. So as I'm gluing things together in Azure for doing whatever it is that I want to do, I can use an app service plan and a set of functions in that app service plan to affect all of those things inside my Azure infrastructure. But reaching back internally is probably, you could do it. It's just going to take some special work, but it's probably not the best tool for the job.
Thanks.
Yeah, I was going to say I saw today where I was just telling a coworker we were talking about. Well, I was telling them about this this presentation that you were doing, and someone said, "Oh, is that like Lambda Function's baby brother?" And I said, "Well, yeah, I guess you could call it that." And we started talking about the comparison, and I said, "Well, I believe Lambda Functions, you can assign like a security group to it, which kind of like our network security groups, and you can attach it to a subnet and a VPC." I was like, you can't do that with Azure. It's all public. And then I'm eating my own words as I went to quickly Google and see. And sure enough, in preview, there's this VNet integration, but it's super weird. Like it looks like you can only go in one direction, outbound or inbound. And
I was about to say you can kind of do it now, kind of.
Yeah, it looks goofy.
Well, it's still in flux at this point. So who knows what's going to happen tomorrow, if not next week, and things like that. Because that's also the kind of the crazy and the weird thing and awesome thing about Azure at this point is it's ever changing and new features and new things are coming as we talk.
There was somebody else.
I think it was pretty cool, Jeremy,
Victor,
though.
Right? Was it Victor that had a question?
Oh yeah, Victor had a question earlier. He's still around?
Probably muted.
He's still there.
Can you guys hear me?
Yes, sir.
There we go.
Question number 1. Wanted to ask you guys. This is what we're referring to, the whole Azure thing and having an account and playing around with it and maybe adding a website there and inquiring some data from another script or from another a server that gives this data about temperature of water or whatnot, what would this in reality as a job be like? Would this be a level 3 job? Would this be a DevOps job? Would this be a database guy job who is binding data from one platform to another, or from one, I don't know, what would in reality this reach out to as a job? maybe I'm not clear enough.
So I would say all of the above.
Yeah.
Serverless as a whole goes, yeah, I mean, anybody could use this. I could see a database admin doing something like this, just as the Azure cron service that goes out and does a bunch of maintenance on a bunch of different Cosmos or SQL or Mongo databases that are running in the cloud. I could see this as a DevOps thing. So where a DevOps engineer is using this to provision and test and build pipelines and interact with the build pipeline that they've created. So there's lots of different situations where using something like Azure Functions can be a useful tool to a lot of these different roles that you've talked about. They're all just going to use a different part of the service a different way.
Right. Another question would be, I wanted to see the file that is being created in your storage whenever you're requesting it. I understand it was 7 a.m. every morning, or maybe I did not remember right. So it's exporting this the results, which are refreshed every day, into your storage. And what is it? A file? Is it a text file? Is it?
It's this right here.
All right.
Which, isn't there a way to like turn JSON data into something nicer than this? Why did this format so weird?
Format F1 format. Hit F1, and then format doc. Type F1 and then type format. Hit F1 and then type the word format.
Yeah, I'm trying.
And format document right there.
There was a weird delay happening. All right, so yeah, so this is what that file looks like. So I'm using that Azure function. It runs at 7 o'clock every morning, and then goes out and grabs all of this, looks at all of the stations that was in that array, and then for those that were up and available, I make a, so like, let's do this, terminal, new terminal, right? So in CD, so I can come in here real quick and let's make an object here, $a, we'll just do object 1 equals object, go. We'll just do first name, last name equals. Let's see if I get this right. It's the top of my head here. What did I type in wrong?
It doesn't like your second value.
No comma. It's a semicolon.
Thank you. Sorry. All right, and then let's do object 2. Keep picking on Mike. All right, so dollar foo equals Oh. Equals, sorry about that. All right, so now $foo is an array of objects, right? So if I take that and say convert, I'll get there, to JSON, so it'll take the object data and write it as a JSON file for me. So that's all that I'm doing. So I'm using an Azure function to take that array of stations, and for all of those stations that are up, I'm just building a custom object for each one, outputting them to an array, and then turning that array into a file. Because the file stores its structured data, right? So this is just a flat file that is storing a bunch of structured data. And then I can use this structured data to read back in as a bunch of objects to use later on, which is what I do with, when the page loads with my JavaScript. Is that a good example?
Awesome. Yes. Another question would be totally unrelated to this. Where would I find this recording and other recordings that you guys did?
If you head to youtube.com/rtpsug, this is our YouTube channel, and we've got a ton of videos in here.
That's so cool. Awesome,
Yeah,
guys.
they'll go for a while, right? So yeah, there's a ton of backlog of content here that you can go and take a look at, and this one will show up there within the next couple weeks.
Amazing. No more questions. Thank you very much.
Hey,
awesome,
no worries,
guys.
man.
Awesome job, guys.
Yeah, and certainly, Victor, if you want to reach out to Mike or myself and let us know if there's any topics that you're interested in, and we're more than happy to see if we can add them to the lineup over the next couple of months and as it goes along. And if we can't, if we don't have an answer for you, we certainly can reach out to the community at large and get you a topic that you're looking for, and you can find out that kind of thing. So we're more than happy to help.
Thank you, guys.
All right, so with that,
so
we're
Jason,
going to
hold
on
okay,
one second, Jeremy.
Sure.
I just want to officially end the recording. We're gonna keep hanging out, guys. We're ending our recording for this evening, so if you guys can just hang out with me and give me about 7 or 8 seconds of silence in case we want to trim the end here. Thanks for attending tonight's thing tonight, guys. I hope you enjoyed it. I want to say thank you to Jeremy Brown for doing a fantastic job tonight on presenting serverless apps. Look for more content like this on our YouTube channel and check us out on our website, rtpsug.com, or on Meetup for future meetings.